Dear viewers, an extraordinary phenomenon has just unfolded in the universe of astronomy. The interstellar comet designated 3I Atlas has been the protagonist of a discovery that has left both researchers and cosmos enthusiasts perplexed. On the 9th of November 2025, astrophotography specialist Frank Nebling managed to capture an image that reveals an extensive radiant tail accompanied by a surprising ejection directed precisely toward our sun. This photograph unveils an intricate architecture never before documented in visitors from other stellar systems, reigniting the enigmas surrounding the mysterious 3I Atlas. This exceptional observation emerges precisely when Avi Loeb, renowned astrophysicist from Harvard University, published a new article on the Medium platform titled "The Impressive Large-Scale Structure of the Anti-Tail and Ejection Streams of 3I Atlas." In this work, Loeb examines the peculiar configuration of the comet's streams and formulates unprecedented questions about its fundamental nature. Are we facing a conventional interstellar comet? Or could it possibly be something considerably more sophisticated, a self-propelled technological vessel? However, it's essential to clarify that Avi Loeb is not making unfounded speculations. The researcher presents hypotheses based on concrete evidence. He emphasizes that while 3I Atlas most likely demonstrates typical behavior of a natural comet, its acceleration, variations in brightness, and now the development of multiple tail structures merit thorough investigation. The photographic record obtained by Frank Nebling is truly stunning. The image reveals two striking features: a luminous fan-shaped tail projecting in the direction opposite to the sun, and a more slender and concentrated stream angled inversely, directed toward our central star. This configuration has generated perplexity among numerous astronomers. Conventionally, cometary tails invariably orient away from the sun, being driven by solar radiation pressure and stellar winds. Observing an ejection oriented in its direction constitutes a rare phenomenon that, when it occurs, generally indicates singular surface activity. The longer tail, occasionally called an anti-tail, appears to project across millions of kilometers in space vacuum. Its formation results from the specific alignment between the comet, our planet, and the sun. Under certain circumstances, when Earth crosses the comet's orbital plane, the debris tail can present an inverted appearance, creating the illusion of being directed toward the sun. However, in this particular case, the observed geometry doesn't completely clarify the phenomenon. Multiple streams and flows become visible. This is not merely an optical tail illusion. Let's now understand why this phenomenon awakens such fascination. Atlas represents an interstellar object, meaning its origin lies beyond the boundaries of our solar system. This constitutes only the third confirmed interstellar visitor, following Oumuamua in 2017 and 2I Borisov in 2019. Each of these objects surprised the scientific community in distinct ways. Oumuamua exhibited anomalous acceleration without presenting a detectable tail. 2I Borisov resembled a conventional comet but originated from another stellar system. Atlas, in turn, amalgamates characteristics of both predecessors, demonstrating visible activity accompanied by peculiar ejection structures and unconventional dynamics. The astronomical community has been monitoring 3I Atlas since mid-2025. The object has already manifested behavioral patterns that challenge our established theoretical models. It experienced slight acceleration after its close passage to the sun and generated radio emissions captured by the Meerkat radio telescope located in South Africa. These radio signals proved compatible with hydroxyl molecules, constituting evidence of water vapor release as the comet experienced heating. However, the most recent images present us with something completely unprecedented: a large-scale anti-tail accompanied by an ejection oriented directly toward the sun. In his recent analysis, Avi Loeb clarifies that if this object were exclusively natural, the ejection would result from irregular heating on the surface. When solar radiation strikes specific ice regions, they sublimate, expelling gases and debris at high velocities. If cometary rotation presents irregularities, these ejections can be projected in various directions, including momentarily toward the sun. Dr. Avi Loeb adds, however, that if the ejection orientation changes in a way incompatible with normal rotation or solar heating, this could suggest phenomena not yet understood. He emphasizes that such observation doesn't imply the comet's artificiality, but establishes precedents for additional investigations. The Galileo project, coordinated by Loeb, has been observing interstellar objects for years, seeking to differentiate natural behaviors from any indication of technological origin. According to Avi Loeb, another recently identified object, C 2025V1, maintains no relation to 3I Atlas. Although positioned between the comet and Earth, it presents completely distinct orbital characteristics. Unless Atlas possesses its own propulsion system, for which no direct evidence yet exists, the two objects remain independent. Nevertheless, the synchronization of these discoveries has stimulated worldwide interest. Researchers now prepare to collect additional data while Atlas approaches Earth during December 2025. This approach will offer an exceptional opportunity to examine its composition, ejection dynamics, and movement in detail. Let's now explore the aspects that confer uniqueness to this image. The anti-tail architecture observable in Nebling's photograph demonstrates that Atlas is expelling massive quantities of microscopic dust particles. Solar radiation disperses through this dust, generating a luminous fan-shaped structure that projects through the cosmos. The bright ejection oriented toward the Sun, conversely, appears to consist of gases instead of particulate material. Spectroscopic analyses indicate that the gas is composed predominantly of carbon monoxide with traces of ammonia. This composition presents subtle differences compared to comets originating from our solar system, which typically contain higher concentrations of water ice. The combination of these characteristics confers on 3I Atlas, a distinctive signature, a comet presenting both particulate and gaseous material activity, forming double tails that intersect in space. This pattern has been documented only occasionally in recorded history and never before in an interstellar object. Let's now consider future scientific expectations. As Atlas continues its trajectory toward maximum Earth approach, astronomers will focus on measuring the velocity and density of its ejections. Through comparison of these parameters with computer simulations, it will be possible to determine if the acceleration observed in preceding months corresponds to the amount of gas being expelled. Should the movement exceed the natural impulse explainable by ejection, this would indicate the operation of additional forces. Various observatories, including the Very Large Telescope of the European Southern Observatory and NASA's Hubble Space Telescope, are organizing to obtain additional images during December and January. The James Webb Space Telescope may also examine the comet's infrared spectrum to detect organic molecules and complex hydrocarbons, providing information about its origin. Simultaneously, the Juno probe, currently orbiting Jupiter, will direct its radio instruments toward 3I Atlas in March 2026, when the comet will transit 53 million kilometers from Jupiter's orbit. This will be an opportunity to verify if the object maintains radio emissions similar to those recorded in October. Let's now discuss emerging theories. While most researchers agree that 3I Atlas constitutes a natural comet, certain uncommon particularities perpetuate scientific debate. First, the orientation of its ejection. Normally, an ejection directed toward the Sun would fade rapidly due to solar wind that would repel it. However, in the new image, the ejection remains sharp and luminous. This could indicate exceptional intensity or the presence of particles denser than conventional cometary gases. Second, the symmetry of its anti-tail. The debris tail presents almost perfect alignment with the comet's orbital plane, requiring extremely stable rotational behavior. For a compact object moving at approximately 100 kilometers per second, such stability is remarkable. Third, cometary acceleration. Information from October suggested that 3I Atlas slightly increased its velocity after maximum solar approach. The acceleration is modest, but measurable. Initially, scientists attributed it to ejection activity, but more recent observations will test this explanation. Let's return to Avi Loeb's perspective. In his publication, Avi Loeb argues that scientific methodology consists of following evidence regardless of its destination. He emphasizes that 3I Atlas offers a natural laboratory to examine the behavior of interstellar objects. If its ejections are exclusively natural, we can understand how icy bodies resist the interstellar journey. However, if anomalies exist that are inexplicable solely by outgassing, then more extraordinary possibilities remain open. Avi Loeb recalls that when Oumuamua crossed our solar system, Its acceleration couldn't be clarified by ejections or solar radiation. It lacked a detectable tail, yet altered velocity. This enigma remains unsolved. Currently, Atlas grants scientists a new opportunity to examine these questions with improved instrumentation and data. He also observes that interstellar comets may represent cosmic messengers from other planetary systems. Through analysis of their composition, we can indirectly study planets orbiting distant stars. Each interstellar object transports material from its natal system, preserved for millions of years. Let's now visualize current events in the cosmos. Atlas navigates through the inner solar system, illuminated by stellar radiation. Its resplendent tail extends for millions of kilometers, scintillating with debris particles that once belonged to another stellar system. From its nucleus, gaseous ejections erupt, one oriented toward the Sun, another projecting toward deep space. The anti-tail expands posteriorly, constituting a thin layer of debris that reflects solar radiation back to Earth. Astronomers worldwide direct their telescopes toward this visitor, documenting its nightly transformations. Each observation contributes elements to the scientific puzzle. As it approaches Earth in December, it will intensify its brightness and facilitate observations. Amateur astronomers equipped with intermediate telescopes will likely be able to detect it as a diffuse and tenuous luminosity in the constellation Capricorn. Professional observatories will examine its light spectrum to identify unusual isotopes that could confirm its interstellar origin. Let's reflect on the significance of this discovery for future perspectives. Whenever an interstellar object enters our solar system, it offers us glimpses of other worlds. These visitors are exceptional. Statistically, only one or two approach sufficiently for detection every few years. Atlas distinguishes itself by being active, luminous, and ideally positioned for investigation. Its detectable tail and unique ejection structures transform it into a dynamic laboratory. The more intensely we investigate it, the greater our understanding of the fundamental components of other planetary systems. If its materials correspond to those of our local comets, this could indicate that vital chemistry is disseminated throughout the galaxy. However, if it diverges, this reveals that planetary systems can form with totally distinct components. Avi Loeb concludes his publication stating that truth will emerge through scientific data. By analyzing velocity, direction, and composition of ejections, researchers can establish whether acceleration is compatible with natural outgassing or if additional forces are operating. Regardless, this will instruct us about how objects transit between stellar systems. While we await December's approach, astronomers will continue collecting information. Subsequent images will assist in mapping the anti-tail's evolution and measuring its duration. If solar ejection maintains activity, this will constitute a precedent in contemporary cometary science. In subsequent months, scientists will publish detailed discoveries from multiple observatories, including the Atacama Array, Hubble Space Telescope, and Juno probe. Each contribution will add layers of understanding to this extraordinary narrative. Until then, Frank Nebling's image remains one of the most spectacular ever obtained of an interstellar visitor, a vibrant and dynamic portrait of a cosmic wanderer captured in its journey between the stars. Thank you for your attention. If you enjoy exploring the cosmos through authentic evidence-based discoveries, remember to rate this video positively, subscribe to our channel, and share it with others fascinated by astronomy.